Our next unit is on implicit differentiation. This is a different process for taking derivatives in which we will take the implicit derivative of a function that's in an implicit form. So the first thing we'll talk about is what is the difference between an explicit form of a function and an implicit form of a function. Well, as you can see in the first two examples, they are functions of y that are solved for x. So if the equation is in the form where it's basically y solved for y in terms of x, this is what we call an explicit function, and all the derivatives we did in the first 5 sections were implicit function or explicit functions. So as you can see, if the equation is in terms of x and y and is not solved for y, like this example, like a circle, x squared plus y squared is equal to 9. This is what we call an implicit form of a function. So again, what you'll see is that it's not solved for y, basically. So we are going to look at some implicit functions and how to take the derivative. This is the first example. As you can see, we are going to take the implicit derivative of this function x squared plus 3y squared equals 3. So you pretty much have a set of steps that you follow when you do the implicit derivative. So that's the first thing we'll discuss. And the first thing you do is you'll take the derivative of both sides. And notice I put d dx to indicate that I'm taking the derivative of the left side and then the derivative of the right side. Now, the key to doing almost all the implicit derivatives, and typically in a textbook, this is how it's taught. You have x and y, and you're going to do derivatives of x basically normally like you would, but then all the time examples where you're doing derivatives of a term that has y in it, you're going to do it differently, and you'll apply the chain rule, which I'll talk about in just a second. So we're basically assuming y is a function of x still. So the first thing you do is, as I have written, is you do the derivative of both sides. So let me do that. Using the power rule, the derivative of x squared is 2x. And then plus, and again, using the power rule again, the derivative of 3y squared would be 2 times 3 would be 6y to the first, or 6y. And we do have to use the chain rule. So what I'm going to write is, to represent the derivative of the inside, will be dy dx. So anytime you take the derivative of a function of y, make sure that you times by dy dx. That's the whole key. And that is because of the chain rule. I probably won't mention that every time. So our strategy is, we can kind of simplify it, is basically if you have x, you just do it the same as you did earlier. Just do the derivative. And then if you have an expression that has y in it, then you do the derivative, but you have to times by dy dx. If you can remember that, I think you can do pretty well. Anyway, to finish out the problem, the derivative of the right side is just 0, because the derivative of 3 is 0. It's a constant. So that's your first step in taking the implicit derivative. The next thing you'll do is just simply solve for dy dx. So if I'm going to solve for dy dx, I will need to take away 2x. I'm going to leave this term basically on the left side. So I'll subtract 2x from both sides. I get negative 2x, which gives me 6y dy dx equals negative 2x. And then I will just divide by 6y, and that gives me negative 2x divided by 6y, which will simplify to negative x over 3y. So that is my implicit derivative. So again, the key is to take the derivative term by term of the equation. Anywhere where you have a function that's a function of y, you need to have times dy dx. And then after you do the derivative part, you will solve for dy dx. So the last part is actually basically algebra. You solve for dy dx. All right, example 2. And this is, again, another implicit function, kind of similar to the last example. So again, I'll do the derivative of the left side. And the right side. And that should be d dx. So we're using implicit derivative to find the derivative. Your equation is 3x squared plus 2y squared equals 5x. So we do the derivative of both sides. So the first step will be taking the derivative. So we'll get derivative of 3x squared is 6x. Remember, it's in this. The only variable is x, so we don't need to use the chain rule. Here, we will have to put dy dx because it is a function of y. So 2y squared's derivative is 4y dy dx equals, and the derivative of 5x is 5. So I took care of the derivative part. Now again, we'll solve for dy dx, which means basically you'll just subtract 6x to move it over to the other side. Just pretend like you're in an algebra course, and then you'll divide by both sides by 4y, so you'll get 5 minus 6x divided by 4y. And that is your implicit derivative. So these all kind of follow a format. The key is to do the derivative on the first step, and then you will either have to solve or isolate out your dy dx term. So, okay, one more example of, and that again is just the solution to number 2. One more example is, again, we're going to use the implicit derivative to find the derivative. So this kind of follow the process that we use. So we'll do derivative of both sides. So let's do the left side first. And notice that this term has 3xy, and I'll explain what we'll have to do here. So let's just go term by term. First term is this 2x, or is just x squared, so the derivative by power rules is 2x. No y there, so we don't have to worry about the putting a dy dx term. Now, in this middle term is a little trickier because we have minus 3xy. So if you look at that, we're timesing x by y. That is a product. So I'm literally going to use the product rule. So I'm just going to set this up. We'll do the derivative of y and times by 3x. And then do the derivative of 3x and times that by y. Just, derivative of second times first plus derivative of first times second. So that's, I'll make a note, is the product rule. And I will do the actual derivatives in a second. And then the last term's y squared on the left. The derivative of y squared is 2y. And again, we do have to times by dy dx because it is an expression of y. And the derivative of 5 is 0. We still have a little work to do with the derivative, so let's finish this out. The derivative of y is 1. And I still have to multiply by dy dx because it is an expression of y. And I move the 3x in front. So 3x times dy dx plus, and notice the next part is the derivative of 3x is 3. Bring the y down. Now I didn't have to do a dy dx term because the y part, I didn't take the derivative of y. I just carried the y along with the derivative of 3x. So I'm literally not taking the derivative of y, so I don't need dy dx in this particular case. And then I'll recopy the 2y dy dx. I kind of did put an extra step in here with the 1 dy dx. You could have just said 3x dy dx, but let's go ahead and write it that way. So this will be 2x plus 3x dy dx plus 3y, bring it down, plus 2y dy dx. Now notice that I do have two terms with dy dx in them. So what I have to do to solve for dy dx is isolate these two terms by taking the other two terms over to the other side. So I'm literally going to bring down the 3x dy dx plus 2y dy dx. These are the terms that have dy dx in them. And I'm going to move the other terms to the right side. And this will allow me to factor out a dy dx from both expressions, leaving 3x plus 2y times dy dx. And I need just to add on here to the bottom. We can now divide both sides by three x plus 2y. And that will give me dy dx, the derivative is negative 2x minus 3y over 3x plus 2y. By the way, this is the same as number 3 in your PowerPoint if you want to go back and look at it. And often I do pause for a second after doing a problem. This if you want to pause the video, but typically I won't leave a long space in between just to shorten the video so they're not so long. But anyway, I'll let you look over to see if there's any. You can email me if you have questions. But again, we do derivative both sides. The thing that was different about this example is we had to do the product rule with this 3xy, and that's how we got 3x dy dx plus 3y for the middle derivative. Okay, there's one more example. It's number 5, and it's finding the slope of an implicit curve. So we're going to use implicit differentiation to find the slope of a tangent line to the curve given by x squared minus xy plus y squared equals 1 at the point 1, 1. So the first thing I'll do here, again, we are going to do, as you can see, we're going to use the implicit derivative. So let's do that. So we'll take the derivative of both sides. The derivative of x squared, let's do the left side first, is 2x. And again here, if we have minus x times y, again, that will be a flag raised, and you will say, hey, I got to do the product rule here. So we will take, basically minus, we'll do derivative of y times x minus, both terms have to be negative because it is negative, minus derivative of x times y, and I'll work that out in just a second, plus 2y is the derivative of y squared, and I need a dy dx term equals 0. And then we end up getting the derivative of y is going to be dy dx, because the derivative of y is 1. So this will be x dy dx. The derivative of x is just 1. I'm just going to write, well, I'll temporarily write 1y just to indicate the derivative of x was 1. Bring down your 2 y dy dx term. Now we can solve for dy dx, so we'll keep our dy dx terms on one side, which is the x dy dx term, negative x dy dx, and then 2y dy dx, and then the other terms are, I'll take the y over, change its sign, so it'll be positive y minus 2x. And then I will factor out dy dx. So I'm going to go and switch those around. So it'll be 2y minus x. I just switched them just to make the leading term positive. So we get 2y minus x times dy dx. And now my derivative will be, when I solve for dy dx, will be minus, it'll be equal to y minus 2x over 2y minus x when we divide both sides by 2y minus x. So there's my derivative. And I have to use this derivative to find the slope. Well, recall with explicit functions what we did was we plugged in the x value because our functions were only of x. Now we have functions of x and y, so we'll just plug in both the x value and the y value, which are both 1. So x is 1, y is 1. So my slope will be, plugging in here, will be 1 minus 2 times 1 over 2 times 1 minus 1. And that's negative 1 divided by 1, which is negative 1. So my slope of my implicit curve is negative 1. And that is the last example. So go ahead and work the WebAssign and book problems. And again, this might be a situation, if I do get some emails about needing more help, I may post some more examples as implicit derivatives part 2 if needed. We'll see how that works out. But anyway, work on the problems. This is the last section in 3. The next video will be the next set of videos will be for chapter 4.